Hi, this is Margo. This is Sunday evening, August 21st, 2022. I hope everyone is safe and doing as well as possible. We made it through another week, and I don't know about everyone else, but time is just flying by for me. It's like I blink and another week has gone by. But I'd like to welcome everyone to the show tonight. This will be my weekly update that I'll be putting on YouTube. And if you'd like to have updates during the week, I'd love to invite you to my Subscribestar channel. The link is in the description box below. And for only $5 a month, you can I do updates every day. I do almost a video every day, and I do posts with earthquakes and different information, and then I do videos almost every day, and I do a midweek update that is similar to the Sunday show, and all that's for my Subscribestar members. So we'd love to have you over there. And so we're going to start out. I'm going to start off the show tonight with the latest post from Sam Carana. This is Arctic News, arctic-news.blogspot.com. And he started this post on August the 10th, and he keeps revising and adding to it, which is fine. You gotta have somewhere to start with, and now that I know what he does, I know that we can just keep coming back and he'll have more updated information. But for the last couple of months, he's been tracking the Arctic, all the conditions in the Arctic, with a blog post. So this is his Arctic sea ice for August 2022 blog post that he's been accumulating the data. And I just want to hit some highlights here. And the first thing he shows is the ocean currents and how they keep pushing heat toward the Arctic Ocean. And this was from NOAA, and this was August the 13th. And you can see the color chart down here, and it's the highest down here in the Gulf of California, and also in the Gulf of Mexico, and then it's still pretty high with the orange heading up in the Atlantic with the Gulf Stream taking it up there. And he says Arctic sea ice is getting very thin as temperatures keep rising and ocean currents keep pushing heat toward the Arctic, as illustrated by the NOAA image below, that shows sea surface temperatures as high as 33 C or 91.4 degrees Fahrenheit on August the 13th. So, and then he says the Gulf Stream is an ocean current that extends into the Arctic Ocean. It's pictured below and discussed at this page with a link. This ocean current is driven by the Coriolis force and by prevailing wind patterns. And so here's the Gulf Stream and how it eventually ends up in the Arctic, coming up the Fram Strait, and also following the Norway coastline and up into the Barents Sea. The ocean current contributes to the stronger and accelerated warming of the Arctic compared to the rest of the world, which in turn causes deformation of the jet stream. We've seen that can at times cause strong winds to speed up this ocean current. The image below shows the jet stream over the North Atlantic, where the ocean current dives under the sea ice. Sea surface temperature anomalies are much lower over the area where the deformed jet stream causes water to evaporate, thus cooling the surface. The danger is that a cold freshwater lid grows at the surface of the North Atlantic that enables large amounts of salty warm water to dive under the sea ice and enter the Arctic Ocean, as discussed earlier here as well as here. He's got links and at the feedbacks page. And so you've got the colder air on the top, and then anyway, the warmer water is trapped underneath this cold lid on the top. And so with that warmer water, he goes into how this warm water gets trapped under the surface, and then it's more prone to melt the methane hydrates in the ocean floor. And then he talks about latent heat. Latent heat is ocean heat that is, or rather was, previously consumed by melting of the sea ice underneath the sea surface. This ice has meanwhile all but disappeared, so without this latent heat buffer, further incoming heat must go elsewhere, i.e. the heat will further raise the temperature of the water, and it will also cause more evaporation to take place, where the sea ice has disappeared altogether, and this in turn will further heat up the atmosphere over the Arctic. Here's an image from Earth Null School on August the 9th, and he's got the green circle here, which is in the Gulf of Ob, just next to the Yamal Peninsula, and sea surface temperature anomalies as high as 10.1 C or 29 degrees Fahrenheit there at that green circle on August the 9th. Now that's higher than what Climate Reanalyzer registers. Their sea surface temperature anomalies only go up to 6 C, higher than normal. But here in Earth Null School, it can go higher than that. And he says back in 1981 to 2011, the temperature at that spot was 0 degrees C. 0 degrees C. And so since then, since 2011, so 11 years, it's gone up that much. And then the thin layer of sea ice and what that means. The image below, adapted from the University of Bremen, shows Arctic sea ice concentration on August 12th, with concentration in a large area close to the North Pole as low as 0%. It's this area right here, and we've been tracking that as well. And you can see this dark air swath that comes up kind of in an arc up from the North Pole up to the Laptev Sea, and that's that's super thin. A lot of open water there. Just a lot of open water in between the pieces of ice. And then you can also see the areas, the darker areas around the edges where it's disintegrating as well. Here's from National Snow and Ice Data Center, sea ice concentration on August the 9th. And now I will go over current conditions as well, but I just wanted to give all this as a background. See all the dark blue, it's breaking up. And then he shows the U.S. Navy Arctic sea ice thickness for August the 18th. And again, I have more recent data than that to show. And the danger, and this all leads up to danger of methane eruptions. The Navy MIL combination image below, Navy military, has 3 panels. The left panel shows the sea ice on August 30th, 2012. Now you have to remember they had a different model they were using in 2012. And but you get the idea. There was a lot more thicker ice, even though the extent was less. It's much thicker. What they had a lot more volume of ice to deal with. And then August 30th, 2015. Now the new model kicked in 2014. And so here we even have got more aqua. Most of the ice that's left is aqua or higher. And then here, August 21st of this year. That's the forecast. And we can see, even though the extent is more, it's very thin and bad ice. And we just have a little bit of aqua down here above the Canadian archipelago. And it's breaking up. And so this ice that we have this year is most of it, well, in quadrants 1 and 2 and quadrant 4, the majority of it is under 1 meter, and a lot of it is under 1/2 meter, like where you see the whitish, that's a lot of open water with just pieces of ice floating like ice cubes. So we saw through the thicker ice, and even here, like the aqua was 2 to 2.5 meters thick, which is what looks like the same chart for all 3. Let's see, there was a lot more aqua and greens and yellows and reds, very little purple or even dark blue. So this was 2 meters or higher. So there's that. Somehow they've managed to keep the extent, whether it's been with weather manipulation or what. They've been able to keep some semblance of an extent, and that has managed to keep us from having a blue ocean event. And then in this chart, this is the extent, and see, as of August 11th, it's kind of in the lower middle, so it's above a whole bunch of years, but that's misleading. You know, we're not out of the woods. There's still a relatively extensive but very thin layer of sea ice present at the surface. This is also illustrated by the NSIDC image on the right that shows an Arctic sea ice extent of 6.438 million square kilometers on August 11th. This relatively large extent is mainly due to the suppression of air temperatures that comes with the current La Nina. And he goes on about how we're still in this La Nina, and we're just waiting for the El Nino to start. As long as air temperatures are low enough to keep this surface ice frozen, and as long as there are no strong winds pushing the ice out of the Arctic Ocean, this thin layer of ice will act as a seal, preventing transfer of heat from the Arctic Ocean to the atmosphere. So that's good and bad. It's good and bad. The larger the remaining sea ice is in extent, the less ocean heat can be transferred from the Arctic Ocean to the atmosphere, which means that more heat will remain in the Arctic Ocean. So here we go. Here's our heat remaining underneath this thin layer of ice. The danger is that ocean heat keeps arriving in the Arctic Ocean while the latent heat buffer is gone, causing more of this heat to reach sediments at the seafloor of the Arctic Ocean that threatens to destabilize hydrates in these sediments, resulting in methane eruptions both from these hydrates and from free gas underneath these hydrates. Free gas. That's the first I've heard about that. And then he switches to methane, high methane levels. Methane levels are already at record high, and growth is accelerating, even without an extra burst of seafloor methane. Well, we're always at a record high because we never go back down to what it was the year before. So we're setting records every day. So, here in this chart from NOAA, April in 2022 was 1909.9 parts per billion, and April 2021 was 1891.2 parts per billion. You can see the line just going straight up now. Recent global monthly mean. Well, that was April. This is August now. And so this is, by comparison, the highest annual growth on the NOAA record of 18.31 parts per billion for 2021. See that? And then he has some NOAA images. NOAA's data are for marine surface measurements. More methane tends to accumulate at higher altitudes, as illustrated by the image on the right. This is at 293 millibars. And on August 11th, this was the mean global methane was 1971 at this level. That's this number here. And I usually only track the 469 millibar level. So this is higher up in the atmosphere, the 293. And then he goes on, when using a 1-year GWP, that's global warming potential, of 200, this translates into 394.2 parts per billion of CO2 equivalent. That's what that all means. So this high methane reading, they can convert it into the equivalent of carbon dioxide, and they convert it into 394. As the image underneath also shows, the MEDOP satellite also recorded a peak methane level of 3009 parts per billion at the 469 millibar reading on August 9th, and I showed that last week. I showed that in my show for y'all last week. See, this high reading, the 3009. And then he switched to carbon dioxide. Record high carbon dioxide levels have been quite high over the past few months. Monthly CO2 was 420.99 ppm both in May and in June. Some hourly CO2 measurements were well above 422 ppm in May. On May 28th, one hourly average at Mauna Loa was recorded at 424. So it fluctuates, and we've had some spikes, is what he's showing. See, look at this chart. This is the Mauna Loa hourly, where it spikes up. And then he talks about clouds. So this is good because this gives us a good overview, and by the end of the month, you've got the whole month here. Clouds feedback. Copernicus, which is CAMS, recorded high concentrations of methane over the Arctic Ocean on August the 16th. And this blowout here at Komsomolets. The image below shows methane at surface level, where the scale goes up to 10,000 parts per billion. At a 1-year global warming potential of 200, this top end of the scale translates to 2,000 ppm CO2 equivalent. That's a lot. 2,000. And, we're at 420 right now for carbon dioxide. This 2,000 ppm CO2 equivalent is well above the 1,200 ppm CO2 equivalent cloud's tipping point that will trigger the disappearance of the lower clouds. The presence of lower clouds and sea ice causes a lot of sunlight to be reflected back into space, so the danger is that at locations where these clouds and sea ice cover have both disappeared, the water of the Arctic Ocean will strongly heat up at this time of year. What makes this situation in the Arctic very dangerous is that there is very little hydroxyl in the air over the Arctic to break down methane. Furthermore, the Arctic Ocean in many places is very shallow, especially off the coast of Siberia, and that's what this image shows. The shallow water all along this coastline. See how far it comes out? Well past this New Siberian Islands, well past. That's the shallow water. And also, most of the Kara Sea is shallow. Here's the Laptev Sea. Here's the East Siberian Sea, Chukchi Sea, Bering Strait, and then all along Alaska, and in this Canadian part. Anywhere you see red and orange. And also see, if you look real close, here's Komsomolets, and that's shallow right around Komsomolets, where we're seeing the methane blowing out there. So we can just assume that that's just one of the areas that's just going to keep blowing out. Shallow waters enable hot surface water to be mixed down all the way to the sea floor. This threatens to trigger destabilization of methane hydrates contained in sediments at the sea floor and result in eruption of huge amounts of methane from such hydrates as well as from free gas. Again, he's saying free gas. I've heard that before. Free gas concentrated in sediments underneath the hydrates, as illustrated by the image on the right. So we've got hydrates and we've got free gas. I guess that's the gas that's not frozen. It's just kind of trapped down there. Let's see. Subsequent releases of methane. This is 2020 up to 2100, the years as if we're going to be here. Abrupt eruption of an additional 5 gigatons of methane from the seafloor of the Arctic Ocean would double the methane in the atmosphere. Just 5 gigatons. An amount of 5 gigaton methane is only 10% of the 50 gigaton that Natalia Shakova et al. Warned about long ago, while 50 gigaton is in turn only a small fraction of all the methane contained in sediments in the Arctic, as illustrated by the image on the right. Let's see. But it's in around all the coastlines. It's not just the Arctic. There's a lot in the Arctic, but it's not only in the Arctic. See, it's around all, around all the coastlines. You see the red. Here's some brown, and that's greater than 2. That's organic carbon. Greater than 2%. Right here, That's just west of Novaya Zemlya. There's the brown there. On its own, a 5 gigaton eruption of seafloor methane could raise the global mean methane concentration by as much as 1,971 parts per billion, which, at a 1-year GWP of 200, would translate into another 394.2 ppm of CO2 equivalent, and when added to the above 815.9 ppm CO2e, adds up to a total of 1,209.39 ppm CO2 equivalent. That's staggering. So that would abruptly cause the joint CO2e of just two greenhouse gases, i.e. methane and CO2, to cross the 1200 ppm clouds tipping point globally and trigger a further 8 degrees C global temperature rise due to the clouds' feedback alone. And here's his chart on potential rise in temperatures. There are further forcers and feedbacks to be taken into account, which means that the cloud's tipping point could be crossed globally, even with a far smaller abrupt release of seafloor methane. While it would take longer for the cloud's tipping points to get crossed that way, the associated temperature rise could be enough to drive humans into extinction well before the tipping point was even reached. A rise of 3°C above pre-industrial could occur on land and drive humans into extinction by 2025. Now, some people think we're already past the 3 degrees C, and even past 3.5 degrees C, depending on who you listen to. And then he talks about the La Nina. As said, sea ice extent is relatively large at the moment because we're currently in the depths of a persistent La Nina, which is suppressing the temperature rise. El Niños typically occur every 3 to 5 years, according to NOAA. So the upcoming El Niño can be expected to occur soon. The NOAA image below indicates that going from the bottom of a La Nina to the peak of an El Niño could make a difference of more than ½ degree C, or 0.9 degrees Fahrenheit. Furthermore, the rise in sunspots from May 2020 to July 2025 could make a difference of some 0.15 degrees C, or 0.27 degrees Fahrenheit. The next El Niño looks set to line up with a high peak in sunspots in a cataclysmic alignment that could push up the temperature enough to cause even more dramatic sea ice loss in the Arctic, resulting in runaway temperature rise. In conclusion, there is growing risk that methane will erupt from the seafloor of the Arctic Ocean and cause a dramatic rise in temperature. Even without such eruption of methane from the seafloor of the Arctic Ocean, temperatures look set to rise strongly soon as we move into an El Niño and face a peak in sunspots. The resulting temperature rise could drive humans extinct as early as in 2025, with temperatures continuing to skyrocket in 2026, making it, in many respects, rather futile to speculate about what will happen beyond 2026. At the same time, the right thing to do now is to help avoid the worst things from happening through comprehensive and effective action as described in the climate plan. So, well, I didn't think I was going to read the whole article, but I did. And, that gives us a real good context as I head into my report now. And so that you can see that the situation is really dire, and just because we don't have a blue ocean event doesn't mean that everything is all right. It's not all right. And so we'll just move on now. Thank you, Sam, for doing that blog post. It helps a lot. And putting all of those different elements together for us. Okay, so we're going to start with Climate Reanalyzer today, just to get an idea. Now the temperatures worldwide have gone down a little bit, so I'm assuming we're still in the La Nina, although some areas are really hot. And so here's the 2-meter temperatures for the world today. We've got some aquas here. This is colder air temperature. This is freezing. See the 0 next to the aqua. Over the Beaufort Sea and in spotty areas around the Arctic, we still have the dark greens, though, around. Also in the Arctic, which is like 8°C, and then the lighter greens are 10°C. Now this is air temperature. You can see we don't have hardly any whites, meaning 40°C or higher, 100 degrees or higher. Over the U.S., very little. And we've got some whites over China. We still have whites, Saudi Arabia, and coming up through the Middle East and across northern Africa, here in the Congo. Here's some whites still in Brazil. Now just be grateful for the cooler temperatures if you happen to be in any of them, because it's not going to stay that way once the El Nino kicks in. Okay, so here's 2-meter temperature anomaly. We've got browns, see, along Russia, here in Russia. There are fires here too, and there's some fires along these coastlines. We've got browns, dark browns, which is about 10 to 12°C higher than normal, and then browns over the Kara Sea, Bering Sea, over most of the Arctic, light brown, and then dark brown on the Siberia coastline. And then, see, Greenland is blue, so that's cooler than normal. And then over this a lot of Canada, northern Canada. It's in the blue, right next to browns, swooping down through the rest of Canada and just part of this western U.S. And then for the other part of the U.S., most of it is cooler than normal. And the jet stream is broken, as we know, and so the cool air escapes and ends up right next to the warmer air. We've got some reds down here over the Antarctic. This is over like the Thwaites Glacier. And anyway, here we've got blues coming down through Russia and so forth. Worldwide, we're down 0.1 C, lower than normal. So that's unusual. The northern hemisphere is still up 0.6 C. The Arctic is still 0.9 C higher than normal. Antarctic is down 3.8 C. Southern hemisphere is down 0.7 C. The tropics are down 0.1 C. So even with an overall lower temperature worldwide, we're still almost 1 C higher than normal in the Arctic. So you can imagine how much higher it would be if the overall temperature was higher. Here's precipitation and clouds. The green is rain. We still have green here in Barents Sea and Kara Sea. Here up in Siberia, next to the ocean there, Alaska, we've got rain coming up through northern Canada and next to Greenland and so on. And New Zealand, Robin was sending me pictures from they call them slips, is where these the sides of mountains just crumble down. It's like a mud avalanche. They just fall, mud and rocks, dirt and rocks, and ends up covering the roads on these mountains, and houses are falling down or in danger of falling down. Structures are falling down because they've had so much rain that water is just saturating the ground, and so that's really dire there. So we've even got rain on this southern tip of South America, and look how far south, even here in the southern Indian Ocean, and freezing rain down there. Here are the jet loops. It's not a stream anymore. Look at how this spreads out, and then again how it spreads down and breaks, causing totally chaotic weather. Look at this. Here's the southern hemisphere. We'll look at sea ice and snow cover in a minute. And here's sea surface temperature anomaly. This is as of Saturday. See, the highest they go is 6C higher than normal. They need to change their chart. So, up here in the Arctic, where the ice has melted, you can see browns and reds. and 2 to 6°C higher than normal. Everywhere it's melted. Hudson Bay, and it looks like we're getting a blob forming here in the Atlantic off the coast of the northern North America. See the red moving out and the brown. Here's the flat view. Now here in the Pacific, we can see the blob is kind of migrated over to the west, and it's red. It had been kind of sitting more over up here to the east, but now it's migrated, and it's not pink yet, but it's red. And see, we've got lots of browns. It's just incredible how much the ocean is holding in. Worldwide, we're up 0.4°C higher than normal. Northern Hemisphere and North Pacific are both up 0.8°C. The North Atlantic is up 0.9°C. The Southern Hemisphere is up 0.1°C, and the Equatorial Pacific is down 0.2°C. So there's that. Now we're going to move on to methane, and I had a question from Larry about I think he was referring to this day of NOAA. This is all missing data. This was white. He's colorblind, and he thought this was blue up here. But no, this is all this area for almost all the northern hemisphere and sweeping down through Australia down to the Antarctic. All of this was missing data. This was for this is the Met-Op-1 satellite, or Met-Op-B, in the morning for the 16th, and it was for all the levels. And see they said the mean was only 1924. Well, that's over half. All of the area that has the highest methane was missing, so I didn't even count this day. And then in the afternoon, this is what it looked like. So again, what looks like blue to you, Larry, is missing data. This is white here for this East Tropic area, and also here in the Atlantic. And this mean was 1932. So I just threw that out. I didn't even count all of that. Didn't mean to do that. Alright, now I have 2 days worth of NOAA data to show. We're going to start with Friday the 19th in the morning. This is the Met-Op-B or Met-Op-1 satellite, and this is the 469 millibar reading. Their mean or average was 1935 parts per billion. The high reading was 2565. In the afternoon, the mean was 1937, and the high reading was 2463. So you can see these have gone down from last week. Usually when we have cooler temperatures, the methane will go down as well. here we are for the 20th, back to the morning. The mean was 1938. The high reading was 2396. And in the afternoon, the mean was 1937. And the high reading was 2355. And we still have some missing data, and all the gray areas it's missing too. But, we're going to count these readings. So, here's our spreadsheet. So, for the 20th, that averages out to be 1937.5 parts per billion, which was the same as our week before. So no change overall this week. So we just got a little straight line there on our chart. And right now we're 8 parts per billion higher than we were this time a year ago. And we're 68 parts per billion higher than when I started recording this on March the 1st of 2019. Now, this is a little unusual to see methane kind of like taking a little nosedive here, but considering that, from what we saw in Sam Carana, we're in an extended La Nina. The overall temperatures have even gone down, and so the methane is going to go down. But we're not at the end of the methane heating up season, not until usually October, and we peaked out here October the 2nd of last year, and that was at 1936. That was our peak, and we're still above the highest it was last year, 1937.5. Alright, let's see what it did this week. So in my show last week, we were at 1937.5, and it had gone down 1.5 that week. So, and then no change overall for this week. So on Sunday, it went up 2 parts per billion. On Monday, it went down 0.5. Tuesday was the day we had all that missing data, so I threw it out. Wednesday, we were at 1938. So it had gone down 1 part per billion from 2 days before. And Thursday, we went down 0.5. Friday, we went down 1.5. And Saturday, we actually went up 1.5 to bring us back up to the 1937.5. So no overall change for this week. And we're 8 parts per billion higher than where we were a year ago. So I did record the data for the 16th with the 1924 and 1935, but we're not counting it in our overall chart, for counting the data. I recorded it, and with the note that it was incomplete data. So there's that. So we're not done with methane rising. not by a long shot. Now, we're going to look at CAMS, Copernicus Atmosphere Monitoring Services, and we're going to look at Saturday the 20th, Arctic view and surface level. Here's our color ledger at the bottom. And the data is for Saturday, and the forecast period is Sunday through Wednesday. So this blobby area around Komsomolets, it's been pretty awful this week. And you can see it's still just billowing. So I think that, you know, it's just blowing out from the seafloor. I think that probably some nuclear material got dumped there. Russia, Novaya Zemlya, and this whole area, they did a lot of nuclear testing and during the Cold War, and dumped a lot of their radioactive material in the Kara Sea, also on the west coast here in the Barents Sea, and there are nuclear submarines that sank that are still at the bottom. So it just makes me think that probably some nuclear material, radioactive, that was hot, that got dumped, and now it's been eating through the sediments, and it's hit an area where, you know, the clathrates have melted and free gas and everything just keeps coming up right here around Komsomolets. That's my theory. And we're not going to know because this is Russia territory, and more than likely this is part of the military area, because the expeditions don't go here. They just don't go here, and they go all along the Siberia coastline. They go in the Kara Sea. They go in the Barents Sea. They go testing all these different areas, but they don't go right here where it's the highest. So there you have it, and that's all I know. And we can see this whole Scandinavian area over to Russia. Look at these high readings. See, it's coming up from the coastlines even. So, you know, this is just not a good scenario. Let's see, high in the interior here. Here's Alaska, here's Canada, and so on. I already know this is going to be a super long show. So, you know, if you have to pause it, get a snack, come back, get in the recliner, take it easy. Here's the North Pole view. Here we can see the whole northern hemisphere. Now, this UK area, it was awful earlier. I don't know if it was this last week or week before last, but this whole area was just like a big black blob and streaming out into the Atlantic. I mean, it's still not good, but it's not like it was. Here's the Persian Gulf filling up and spilling over, see, into Saudi Arabia. Here's India. See it spilling over the coastline and into the Bengal Bay. Here's China, Korea. See these waves, see the waves moving out. That's high methane. Here in the US, see all the blobs. Usual areas, but also if it's rained, then within a day or two, wherever it's rained, then you'll see higher methane. Look at Mexico and down into Central America. There's that. Now we'll go to the global view. So, this main background color in the southern hemisphere is at 1860 parts per billion. We've got a little wisp of the lower reading of 1840 here in the Pacific, and here in the Indian Ocean, and here in the West Pacific. That's as a result of a little bit cooler temperatures. But overall, I mean, we're just under the dome, the methane dome. So there's that. Here's 500 HPA, that's about halfway up in the atmosphere. And see all these dark areas. It's where it's highest, from Japan over to India, and then moving on over west. So it's kind of broken up, but here's some, that's Russia, and then over the Arctic Ocean. And these reds and oranges are coming further south. See the yellow down here? That's even a higher reading over the Antarctic. And now total column. This is where all the levels are added up through the atmosphere. So you have the highest readings from Japan. Look at this straight line all the way over to Saudi Arabia, and then reds on out. So there's that. Next, let's see, I'm going to close that, and here, this is from CAMS. This is the smoke and wildfires. This is the Arctic view. We've got some fires, it looks like right on the coast of here in Siberia, at this next to the Laptev Sea, and also further east. So we've got smoke coming over. There's some other smoke, different areas. Here's some smoke, Western Russia, and then Canada, the fires, where the fires are picking up in North America. Here, this is Idaho and Washington State, and then Canada. So some areas that, they do have fires burning, but it's nothing like last year and the year before last for us here in the U.S., and I'm very grateful. And, remember all the fires we saw in Russia last year and year before. I mean, it's not like what it was. And I'm very grateful for that, and it's just a lot more tolerable if the air is not so polluted. And so it's been a lot more tolerable summer for me. Here's sulfur dioxide. We have a high reading here in the Philippines, and here it is at 500 HPa. So you can see it's heavy there, just shot right up in the Philippines. So that's could be earthquake, probably earthquake and volcano related. And here's at Kamchatka, see the red where it shot up, that's volcano related, and so on. Here's the ozone hole over the Antarctic, and we've got this area in the danger zone inside this black line, the bluish purple. This is between 200 and 220 Dobson units. That's considered in very low ozone over this western peninsula. Then we've got a break, see, that goes up to South America, and we've got aqua and green. So this whole continent, the whole continent is quite thin. Of course, it's been in the dark all winter, and the sun's coming up. We'll look at it, but the majority of the continent is still in the dark. Here's the Arctic view of the ozone. And see all the greens coming straight across, all the way across to Canada, and then here along the Kara Sea, Barents Sea, and then Russia, and then Kamchatka, and then Canada, and then the light greens, the yellow greens, that's also thinner than average. But we've got reds coming in too. But this means that more radiation is coming in, and so it'll break down the sea ice faster too and heat things up. Here's the global view of the ozone. See all the greens. And here's this area around Indonesia and in the Indian Ocean and this northern part of Australia. This is like perpetually thin. Also here around South America too. The equatorial regions. We'll look at earthquakes in a little more detail in a minute. I just took a couple of pictures today where there were 203 worldwide today. That's a lower number, but if you look right here, just south of Iceland, here in the Atlantic Ocean, this is on the Reykjanes Ridge. There were 3 stacked up right on the red line. Here's Iceland and Greenland. And so it's 4.7, and the largest was this 5.5, and then a 4.4, all today. And it started at 8:27 this morning, 4.7, and then at the 5.1 at 8:28, and then the 4.4 was at 9:32. That's Pacific time. So 3 within an hour here. And that's all those. Now we'll move into the sea ice part of our report. And this is from Climate Reanalyzer. This is sea ice and snow cover for today. And we can see the breakdown in the ice here, just north of the North Pole. There's so much open water, it's unbelievable. And here in the basin, and then here, look at the Beaufort Sea, Chukchi Sea, and across. So the extent, if you're just looking at extent, you say, oh, that's good, we're not in any trouble. But I've already shown how thin everything is. So we'll go back from last Sunday. Here we were on the 14th in the show last week, and we'll see what it's done this week. So here's Sunday, Monday, look at that change. Tuesday, Wednesday, Thursday, Friday, Saturday, and then today. So there's that. And then our other models. Here's the U.S. Navy, sea ice thickness for the Arctic. This is for today. So, we know that it's thin and slushy and lots of open water. Wherever you see the light purple. And so I'm really focusing more on what's left of the thicker sea ice above Greenland and Canada. And the North Pole is right here. It's about 1 meter thick in that dark blue, moving in the purple. And so we just see a little bit of the bright aqua that's about 2.5 meters thick. Then it's mainly darker aqua, and you see the dark lines. That's where it's breaking off and disintegrating. So we're getting, the ice is really coming apart, and there's a breaking off here on the west side. And then here in the archipelago, we still have light lavender, just almost nothing ice there. We've still got this hole on the north end of Greenland. Now we're getting a little bit thicker ice building up on the Greenland coastline. That might be from ice drift pushing against it. I don't know. Here's the 30-day animation. This was updated to yesterday, so the data goes back 3 weeks, and the forecast period goes to next Saturday. So we're seeing an overall thinning, and it doesn't look like we're going to have a blue ocean event simply because of this extent. And they count all the little nubs. They don't count the open water in between the pieces of ice, and it can be miles of open water. They don't count that. So, but volume-wise, we're at the lowest, I think, or close to the lowest volume-wise. Zach LaBaye is, he has all his charts that he reports on all of that. So we can see it's thinning down and it's spreading out. This replay of kind of what it did last year, except it was more rounded last year. And last year we had thicker ice here in the Beaufort Sea. It kind of had more of a tail that came out. We don't have that thick ice in the Beaufort Sea this year. So you can see the lines where it's breaking off. That's where the leads are coming apart. And we're still in the melt season. It'll keep melting until around mid-September, around the extent at least we'll reach minimum usually around September 15th, maybe around the 15th or the 19th. It could be later than that, I don't know. It just depends on what happens with our La Nina. So here we are. I stopped it at the end. This is for next Saturday. See the dark line coming across? Now here, it looks like the ice is piling back up along the Greenland coastline. It's probably from ice drift pushing it back. We're still right around 1 meter thick here at the North Pole. And it's more stretching out into a straight line. And look at all this melting in these tributaries. It's like almost not there, just wispy. So let's go through this week and see what it's forecasting. Not much change on the extent, mainly on the thickness. Okay, here we are today. Okay, here's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Oh, I'm off. Here we are today. I was off one day. Anyway, you get the idea. That's for next Sunday. There's that. Here's the Beaufort sea ice thickness. Here's Canada, and here's our break here. And the Beaufort Sea. See all the white. A lot of open water. Here's the 30-day animation. It was updated to today. So the forecast goes out to next Sunday. Now it looks like we're losing extent still here in the Beaufort Sea and thinning way down, and see it sliding down. And here we are. One more. Here we are next Sunday, where they're expecting it to be. See all this open water around the little islands. And moving to the Antarctic now. It's thickening here in the Ross Sea and around the coastlines. More thickening here in the Weddell Sea. And a little more extent coming out. Now the sun is up for a lot of this western peninsula. A lot of the Weddell Sea is in the sun now. A lot of this eastern side is in the sun. Here's the 30-day animation. Again, this was updated to yesterday, so the forecast goes out to next Saturday. So it keeps growing out to the maximum, usually around early September or mid-September. Last year we reached maximum at the end of August, so it was early. There's that. And now National Snow and Ice Data Center. This is as of yesterday. Sea ice concentration. So the dark blues, that's where it's disintegrating. Now we're seeing more concentrated here. In this basin area. I don't know if it's because of the colder air. I don't know. It could be. And here's the extent. Here's the chart. The blue line is this year, dotted line is 2012, and the gray line is the median. So we're still well below the median, but we're quite a bit higher than 2012 still. And here's our chart. The readings were about it's right at that 6 million square kilometers. It looks like, or it might be a little below it now. So there's that. Here's Greenland. I forgot. Where's the Antarctic? Let me see if I got it. Hold on. Somehow I misnumbered these. Got them out of order. So here's the Antarctic for yesterday. Sea ice concentration, the brownish line, that's the median. Still pretty far under that. And here's the extent. Here we are this year with the refreeze. This was last year with the green line. This is the median with the gray line. And it looks like it's kind of stalled out again. So here's where it peaked out last year, right at the end of August. So we could be reaching the maximum in short order with it kind of stalling out like that. And okay, let's go back. Let's get Greenland. Uh-oh, I lost it. Wait. Lost Greenland. There we go. Here's the surface melt for yesterday. You can see it's gone way, way, way down. Just a few areas are still melting. A few right at the top, just dots here and around, and at the bottom. Here's the cumulative melt days for this year. So anywhere you see a color that's not white, that means it's melted at least one day during the year. And up into getting into the reds, 70 and 80 days. This is pretty high. See right down here, the dark red. Here's the chart for melt extent. Now, Greenland melting should be winding down. It looks like we're just below the median, like 1% or something like that. So the highest it got was here at 42%. That was around mid-July. That's all of those. Now, we'll move on to NASA Worldview. Here's the Arctic. We're going to start with the Antarctic, though. Let's refresh. Here we are. So you can see where it's in the sun now at this western peninsula. Here's the Weddell Sea where it's frozen all the way out up here. And see, sun's come up on this east side. And the Ross Sea, see, the ice comes all the way down here. So we're going to start up here with our iceberg A76 that we're tracking. Here it is, and it's broken free of the ice. So I'll show you what it's done this week. The 14th was last week, last Sunday. See, here it was. It's mainly rotated, kind of this top end is rotating to the left. Now there are some islands right here that I'm afraid it's going to run into. So I don't know what their plan is. See these islands? It's not very far. Here's the tip of the western peninsula. Here's some more islands. And then these couple of little islands are kind of off by themselves. So here was the 15th. Look at this. Here's the 16th. And you can see the islands. Look at these lines. And see, it's right next to the ice there on the 16th. Here's the 17th. See, it's really rotating. Here's the 18th. Look at that. Look at how the hole in the cloud there. And see, it broke away from the ice there on the 18th. Here's the 19th. See, it's really broken away. And here we are today. I mean, yesterday, the 20th. Look at that. And the 21st. And at this rate, if it keeps rotating, it's going to hit these islands. So, I don't know what they're going to do. But we'll be watching. And we can't really see Pine Island Glacier or Thwaites. That's not in view yet. And let's see, what can we see down here? Go to yesterday. See, it's different on different days. Here's the Totten Glacier, and we've got these weird colors because the sun is at an angle, like real low. Look at this hole. Right, it's so. I wonder why that didn't refreeze. So here's the tongue. 19th. Oh, here's the 18th. See, there's a hole up in there. See, you can see where it refroze. Remember how there had been big long crack there. There's yesterday, and today that's not visible in the model. Alright, then come on around. Here's the ice, see, out here. So it's the extent is still inching out. Just barely. Here's the Amory ice shelf. There's a cloud. If we go back. Okay, here's a good view. And here's where the sea ice is formed. See? And then here's the ledge. But that's what the ice looks like. And here's the north side. And here's the ice edge all the way up here. Here's some more land. Oh. See, it goes all the way up there. And there's the coastline. And so on. And that's about all we can see down here. That nighttime layer is just doesn't, you can't really see that much with it. And they have a note up saying that they're still working on it. Here we are today on the Arctic. And we can see smoke. There's smoke coming up here. And over here. So we'll start with our sea ice concentration layer and take away the clouds. You see this ice? This is just wispy ice, but I'm kind of surprised to see that. I guess because of the cooler air. Well, no, that's in the brown, and with the sea surface temperature higher, I'm definitely surprised to see that wisp of ice formed there in the Barents Sea. So you just never know. And see, we've got some showing up here in the Hudson Bay too. So we'll go back to last Sunday. Here we were in our show last Sunday, and now we'll click through and see what's happened this week. So there's Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then today. So we're definitely seeing holes open up in these areas. Of Wherever you see colors, that means it's melting. And we have not nearly as much white area on this model. That's the concentration. So each model is a little different. So we'll turn on the clouds, turn off that, and let's go in, see what's going on. We'll start up here at Greenland. Here's the ice. So it looks like that hole is filled up, or close to being filled up. Here it was yesterday. Here's a hole. See? Oh, look at that cloud. So we got a cloud right over it. There's still a hole there. See, you can see through the cloud. See? Here's the Lincoln Sea. Now that had broken up last week. I don't know why that's all put back together. No, it's not. See, you can see through the camouflage there. That's still broken up. Here's the nearest strait. See, it's still coming through. And here's the Greenland ice sheet. See if we can see any melt ponds. Yeah, there's still these blue areas, the melt ponds, where it's water standing on the ice where it's melted. See? That's opened up. There's a big cloud. And here's the southern tip. So here's our rain next to Greenland. Here's some ice. It's almost not there. Now, let's go. Let's head up. So here's the North Pole right there. Now, let's find our holes. Here's some. Look at this. You kind of have to go look through the cloud, but there's a lot of open water. See that? See the dark color? That's all open water. So just imagine without the clouds how much open water we would see. And see, these pieces are getting further and further apart. And they're getting smaller because it's melting. Look at this. This is yesterday. Look at this. See, they count all of that, but look at all that open water. See? Ships would not have a problem getting through there. No problemo at all. Here's today. Of course, it would be cloud covered for our show. Okay, here's smoke. See, this is smoke. The fires are burning right there on the coastline. Can't really see, but you can see the smoke coming up. See? Look at all this. This is the Laptev Sea here. We don't have a good view without the clouds, but just suffice it to say this is open. And look how this is opened. This is New Siberian Islands. Here's the Siberia coastline, and that's all open, see, and here's where it's melting. Here's the ice, and here's the Bering Strait. Here's the Beaufort Sea. And we're looking through some clouds, but see that? That's slush. That's just so thin. And then here. And then coming along, see, here's open, open, and this is Ellesmere Island. See how that's opened up there, and look at this inside. That's all melted this week. And there's the North Pole. And we've got plenty of clouds. But you can, once you get a little break, you can see what poor condition that's in. It's yesterday. Here's the 19th. Just lots of clouds and that wispy layer that we know about. And then, looking over here, here's Svalbard, and they got rain this week. Look at all the algae. See the green? That's algae growing. And Longyearbyen is right down in here. That's where the seed vault is. and doesn't look like much snow there. It's almost all melted. There's no Viazimlia. I just still can't believe that there's any kind of ice up here. Here's the Kerosene that's open. And here's Komsomolets right here. Oh, I wanted to show over here. Look at this. This is New Siberian Islands. This is the Vovolov ice cap. I don't know why the name isn't showing up, but anyway, this is where, see, it's pouring into the ocean there. This was on the 19th. And here's the ice just pouring into the ocean. You can see the flow. And here's where the ice has melted that had been around it. But see, it's just pouring out still. And I'm sure these others are melting too. You don't see them pouring into the ocean like that one though. And here's Komsomolets. And so it's right around here, this whole area, that we're seeing the continuous billowing of methane. And here's the ice. This is the 19th. That's a good view. Look at this. So there's that. It's today. Now we'll quickly look at earthquakes. 188 worldwide. So that number's gone down even since I started the show. Let's see, 7 days, all magnitudes. So for this week we've had 1,792 earthquakes. Of all magnitudes, let's see, 4.5 or higher, 86 that were 4.5 magnitude or higher. Here's a 5.0 at Okeok, Alaska. Trying to think, did we have any 6s? I think they were mainly 4s and 5s. Yeah, no 6s or above this week. They were all 4s and 5s. So all magnitudes again. And just the usual areas. Oops, I Didn't mean to go that fast. More movement on the Juan de Fuca plate. 4.4 there, and a 2.8. And just constant movement here. Nevada, California, and the Cascadia zone. Cascadia zone. I started squeaking. I'm losing my voice. Anyway, that's my report for tonight. And we'll bring it back to a spiritual perspective. Continuing to read out of the book of wisdom that was written by Solomon. This is from the Apocrypha, not the Bible. This one didn't make it into the Bible, but still very valid. Wisdom chapter 15. But thou, O God, art gracious and true, long-suffering, and in mercy ordering all things. For if we sin, we are thine, knowing thy power, but we will not sin, knowing that we are counted thine. For to know thee is perfect righteousness, yea, to know thy power is the root of immortality. For neither did the mischievous invention of men deceive us, nor an image spotted with diverse colors, the painter's fruitless labor. The sight whereof enticeth fools to lust after it, and so they desire the form of a dead image that hath no breath. Both they that make them, they that desire them, and they that worship them, are lovers of evil things, and are worthy to have such things to trust upon. For the potter, tempering soft earth, fashioneth every vessel with much labor for our service. Yea, of the same clay he maketh both the vessels that serve for clean uses, and likewise also all such as serve to the contrary. But what is the use of either sort? The potter himself is the judge. And employing his labours lewdly, he maketh a vain god of the same clay, even he which a little before was made of earth himself, and within a little while after returneth to the same, out when his life which was lent him shall be demanded. Notwithstanding his care is, not that he shall have much labor, nor that his life is short, but striveth to excel goldsmiths and silversmiths, and endeavoureth to do like the workers in brass, and counteth it his glory to make counterfeit things. His heart is ashes, his hope is more vile than earth, and his life of less value than clay. Forasmuch as he knew not his Maker, and him that inspired into him an active soul, and breathed in a living spirit. But they counted our life a pastime, and our time here a market for gain. For say they, we must be getting every way, though it be by evil means. For this man that of earthly matter maketh brittle vessels and graven images, knoweth himself to offend above all others. And all the enemies of thy people that hold them in subjection are most foolish, and are more miserable than very babes. For they counted all the idols of the heathen to be gods, which neither have the use of eyes to see, nor noses to draw breath, nor ears to hear, nor fingers of hands to handle, and as for their feet, they are slow to go. For man made them, and he that borrowed his own spirit fashioned them. But no man can make a god like unto himself. For being mortal, he worketh a dead thing with wicked hands. For he himself is better than the things which he worshippeth, whereas he lived once, but they never. Yes, they worship those beasts also that are most hateful. For being compared together, some are worse than others, neither are they beautiful, so much as to be desired in respect of beasts, for they went without the praise of God and his blessing. Wisdom chapter 15. So I'll be praying for everyone. If you haven't given your life to Jesus Christ, I highly recommend it, that you do it before it's too late. Time is very short. I love you all. I hope you have a good week, and Lord willing, we'll be here next Sunday and do another report. God bless you. Go in peace, and I'll talk to you soon. Good night.